All right, where did we leave off? I don't want to not get one. Okay, transformations. We're going to do that after we do inverse functions. Okay, so find the inverse of. So this first one is 2x cubed plus 3. So there's two things you do. You switch the x and the y, and then you solve for y, right? So instead of f of x, you're going to have x equals 2y cubed plus 3. Okay, and now we need to solve for y. So I'm going to switch these around. I'm going to put my 2y cubed on this side. And then let's subtract 3 from both sides. Then I get x minus 3. Then when I divide both sides by 2, I'm going to get y cubed is equal to x minus 3 all over 2. Then to get y by itself, do you remember this? We can practice this. To get rid of y cubed, we can multiply, or we can take it to the power of 1/3. So actually, you could write it like this. Our f inverse of x is equal to, parenthesis, x minus 3 over 2 to the power of 1/3. And that could be what that one looks like. All right, so this next one, just switch the x and the y, solve for y. Cool, 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 cool. So we're going to have x equals, and then why don't we just do this? 3y minus 5 to the 1/3 power. Sometimes it's easier to write. Now if I cube both sides, I get, and I'm going to switch again, you guys. We're going to do just 3y minus 5 equals x cubed. Then add 5, so x cubed plus 5, divide by 3. So that should be the inverse, but please write it. Make sure we do g inverse of x. Okay. And now finding the inverse of h. So this one, I'm going to go down a little bit so well, maybe I'll just skip over that. So we're going to have x equals 8y minus 5 over 7. Let's cross multiply, so I'll just put a 1 there. So then I get 8y minus 5 times 1 on one side, which I will just leave 8y minus 5 is equal to 7x. What are we solving for? Y. So 7x plus 5. And then divided by 8. So these are easy compared to your homework, which is good because your homework's worth a lot less money, a lot less points than your test. Okay, there's transforming functions. Transforming. Oh, and how can are the following functions even, odd, or neither? So we can look at that by finding the inverses, right? So if you look at your notes, we know that we need to take f of the negative x and see how they match up. So first we have, maybe I should have done this with composition. Well, that's okay. This is fine. Equals 2, and so instead of x to the 4th, we have negative x to the 4th, plus 3x squared, but instead of having x squared, we have negative x squared minus 3. But, so the cool thing about this, I've entered in negative x, but negative x to the 4th power, that's just the same as positive x to the 4th power. You're going to get, if it's negative 1 to the 4th power, you're going to get positive 1. If it's positive 1 to the 4th power, you're going to get positive 1. So same over here. So we're going to get plus 3x squared minus 3. So what we get when we input negative x, well, it's the same exact thing that we get if we input positive x. If that is the case, if f of x is equal to f of negative x, right? Then we know that these are even Steven functions, okay? So odd functions are if we enter in the negative and we get a negative answer, okay? So let's see if I bet one of these is a negative function and one of them is neither, if we can't get that. So let's try g of x here. So we have, I want to do g of negative x, which is going to be equal to 7 negative x to the 5th power, which is going to be, and then plus 3 times negative x cubed minus 3. All right, so this is going to end up to be, since this is going to end up to be negative x to the 5th power, right? I'm going to do this over here, negative x to the 5th power. Negative x to the 5th power is the same as negative 1. Negative 1 times x to the 5th power. So then we can make that negative 7, because negative 1 times 7 is going to be negative 7x to the 5th power. So what has happened is our positive 7 has become negative 7. The same thing's going to happen here. So it's going to be minus 3x cubed. But the problem is, which is the opposite of what's happening here. So it was a positive, became a negative. This was a positive, became a negative. But the problem is this negative 3 at the end, that's a constant. So that's just going to stay negative 3. So each term has not become negative. So we cannot say, so g of negative x is not equal to negative g of x. They are not equal to each other, which means it's not odd. It is also not even, so this is neither. We can also say that g of negative x is not equal to g of positive x. So if it's neither one of those things, this is not even nor odd. It is not even nor odd. It is not odd nor even, because it doesn't, neither one of those is correct. But over here, this will be. If we put in h of negative x, right, we're going to get 2 times negative x cubed plus 6 times negative x. Well, this just becomes negative 6. So it was positive, it becomes negative. This becomes negative 2x cubed, was positive, becomes negative. So if, look over here. Look over here. If I had taken the whole original output, which was 2x cubed plus 6x, and I had distributed a negative, I would get negative 2x cubed minus 6x, right? So in fact, this last one is odd because h of negative x is equal to negative h of x, as if I had just taken a negative and multiplied it the whole way through. So this one's even, this one's neither, this one's odd. And the reason that works is because even and odd functions are reflective over the line y equals x. I think actually I better double check that, but I'll tell you tomorrow for sure if that's correct. So that's going to be the one on, and this was the video on, what did we just do? Inverse functions.